Hello guys, so yeah, today we're gonna talk about the CIS rule. Just gonna go over the basics of what is CIS. Okay, so if you don't know what CIS is, you can go and check it out. CIS, so it's not CIS like SIS, it's CIS, the CIS rule. Okay, so introduction to 6 theta rule. So CIS is a combination of two functions. Okay, so the function of cis theta is a shorthand way of writing the equivalent expression cos theta plus I times sine theta. Okay, so these are the functions that I was telling you about. Okay, and by definition cis theta is equals to cos theta plus I times sine theta. So this form simplifies complex arithmetic and allows the study of complex analysis, as well as reduces the workload in writing the whole expressions, okay? So with that, we're gonna do the purpose of using the cis theta, the cis rule, okay? So the purpose of using the cis rule is the use of the trigonometric values to represent the real and imaginary portions of an associated complex number in the standard rectangular form. If you don't know what the rectangular form is, you can go in the standard open bracket rectangular form. I did the video about the rectangular form back in the previous video I did. I think those the last 2 videos of mathematics that I did, the first and last ones, I did only 2, so they were just all about the standard form, the rectangular form of complex numbers. So you can go and check them out in my videos in the mathematics playlist. Okay, so in the standard rectangular form, a complex number would be represented as a plus bi. So bi, it's an imaginary number. Okay, a is, okay, let's read the passage. However, on a complex number plane, if you know, all of us, I'm pretty sure by now we all know what the Cartesian plane is. So the Cartesian plane, it's this plane we draw when we want to find the coordinates of a certain number or a certain point. Okay, so in the Cartesian plane, we use x and the y axis. Okay, so we're just trying to find the x and the y axis. So here it's a bit different. It's a complex number plane now. It's no longer a Cartesian plane, but a complex number plane. So we know that we have x and y in the Cartesian plane, right? Cartesian plane. So here we have a and b, no longer x and y, right? So okay, let's a, like I said, a are real numbers. So the passage says the a, of which is the real value, is associated with the x-axis. Okay, remember we had something like if I remember, we had something like x and y. So now, okay, let's continue. X is represented by the a value, okay, the a value, and the b, of which I told you that the b is the imaginary number. So whenever you take an imaginary number, you also take the sign of the number. You don't leave behind. If it was negative b, then negative b would be the imaginary number, the imaginary value that will be associated with the x-axis. Okay, yes. So don't forget, you must always take whatever value that you have, take it with its sign if you want to draw it on the Cartesian plane or the complex number plane. If it's negative a plus bi, so you note b is positive, so it has to be on the positive side of the y-axis, of which now in complex numbers, the Cartesian plane, we draw it in a different way. Okay, so we draw it in a different way. It's very, very different, but it's almost the same as the Cartesian plane. So I'm just gonna check this out for you guys because I drew it somewhere, so I just want to show you. I cannot show you right now because if I didn't put it here, but I'm just going to explain to you. So the y-axis in the Cartesian plane, we have the y-axis, of which that is the the vertical line, right? So the vertical line in the Cartesian plane is called the y-axis plane, the y-axis line, okay? But here in this plane, in the complex number plane, we no longer use the y-axis. We no longer label it as the y-axis, okay? We label it as the I-axis, the imaginary axis, of which that is where the imaginary value, the imaginary number lies, okay? So instead of writing it, when you draw the complex number plane, you have to label it like -0 at the middle of the complex number plane, and then from the 0 downwards, we all know those are the negative horizontal numbers, right? In the horizontal line, from 0 downwards, it starts with -1. It's 0, -1, -2, sorry, -2, -3, -4, -5. So those are the negative numbers on the vertical line, okay? And then from 0 upwards, going up, those are the positive numbers of the vertical line, okay? So we have 0, 1, 2, 3, 4 till infinity. If we want a million, so we can write it till a million, but you can just cut it and write it in 2s or in 3s until you reach. But in 3s, I don't think it's best when if you want to find the coordinate of 1,000, let's maybe 1,000, 1,000 and a whatever and a 2. Those are even numbers, so I think it's best when you write it in when you write the values. If you want to cut the numbers, cut them in even values, okay? Don't use odd values because it's gonna give you a messed up graph. So it's best when you cut them in what? In even values. So if you're gonna start, it's 4, 8, 12, you see, 2, 4, 6, 8. Don't, if you want, because 1,000, you know, it's an even number. So what if now you go and then you reach 999? So 999, maybe something like that, is very close to 1,000, and then 999, and then you skip to 1,002. You see, now that is messed up. So you're just gonna confuse yourself. So it's best when we deal with odd numbers. Maybe you can use the cutting the numbers in odds, you know, cutting the plane in odd numbers. But if you're using even numbers, cut the plane in even numbers, okay? That's just something I want to point out, and I hope like everyone gets that. Why do I say that you must cut it in even numbers? So as I said, like the y-axis is now the I-axis, the imaginary axis, the imaginary line for imaginary values, okay? And then the x-axis, of which that is the horizontal line. The horizontal line was represented by the x-axis in the Cartesian plane, but now we're using the complex number plane. The x-axis is represented by a real number. So now if we want to use the real number, so it's the r-axis, okay? That is the r-axis, the real number axis, okay? So that's where all a is represented, is a representation of a real number. So that's where a goes in the r line, in the r-axis. That's where in the r-axis, that's where you put your a value. If it's 1, you put 1 on the right hand side of the Cartesian plane, because from the middle to the right hand side of your side, yeah, basically your side, it's kind of complicating, but from the middle to the right, it's the positive real numbers, and from the 0 to the left hand side, those are the negative real numbers, okay? So yeah, let's continue. Okay, let's read the passage one last time. The a, of which that is the real value, is associated with the x-axis, of which now we call it the r-axis, the real number axis, and the b, of which that is the imaginary value, is associated with the y-axis, of which now we call it the what? The imaginary axis, okay? So that's a complex number plane. That's simply the definition, my definition of the complex number plane. So therefore, any complex number represented as a coordinate pair on the plane can be identified by its distance from the origin okay, r and its vector or angle theta, okay, above the positive x-axis, above the positive r-axis, okay. Essentially, a coordinate AB which represents a complex number is converted into a polar equivalent r, real number, and theta, that's an imaginary number, okay. Let's move on. So now, in this way, all complex numbers can be written a plus bi is equals to r times cis theta, okay. So there's something that I didn't do here, but I'm gonna go through it. If I think I didn't put it here, but I'm just gonna, you know, try to explain to you guys, okay. But I think it's here. I just need to go further, okay. Okay, so in this way, all complex numbers can be written as a plus bi, that's a real number plus an imaginary number, is equals to r times, I think r here represents the modulus, yes, modulus times cis theta. Cis theta can be the argument, okay. Okay, where a is equals to, remember now we're looking for a plus bi, so a, always the imaginary number, the real number, sorry, the real number a is represented as r modulus times cos theta, okay, and then b as modulus r times sine theta. Okay, we're gonna come and explain all of this. You're gonna see it when we have the whole equation of cis theta, the cis rule, okay. As long as the same theta and the same r are used for each of the real and imaginary portions, therefore r, that's the modulus, r is equals to square root a squared plus b squared. If you see this r is equals to square root a squared plus b squared, you know a certain formula that almost the same as this one. We use it in physics most of the time, and maybe in mathematics, where we calculate what? Distance, okay. We calculate distance using almost the same formula. We just, instead of r, we use d for distance. So here we use r because we're looking for a modulus, even though it's kind of the same as the distance, but we need to put the correct value, the correct symbol for the correct equation for a correct calculation, right? You cannot use d here where we're not calculating distance but looking for a modulus, okay. So and in a simple form, some people, maybe they were not taught how do we get the square root. Why do we use a square root of a squared plus b squared? The reason why, okay, this goes like this, okay. Here we have a number that is, let me just write it down, like not write it down but explain to you. So when I explain, just write it down, write this. So I'm just gonna give you this. R is equals to a, let's put it inside brackets, open brackets, r is equals to a plus b. You remember that, a plus bi. So let's a plus b, because b is an imaginary number, right? So a, the real number, plus b, the imaginary number, okay. Then close brackets, and then to the power squared, to the power 2, okay, to the power 2 or power squared. So to do that, we move to the next step. So everything inside the bracket has to have a square root, okay, because not a square root, sorry, an exponent of 2, the power of 2, because now it's inside the bracket, so we have to, everything must be multiplied to the power of 2. So now in the next step, we're going to have r squared is equals to a squared plus b squared. We haven't reached the part where we're going to explain the square root. So then after that, so I think I need to rush because I don't have much time. Okay, so I won't rush too much. So okay, we have r squared is equals to a squared plus b squared. So the answer, distance, you cannot say distance squared is equals to no, we have to get rid of the square, right, of the, to the power 2, the exponent 2. So to remove a square, we use the square root. Okay, so a square root actually, there's before, not before, but above that curving, that sharp v like symbol, there's this 2 here. So to get rid of the square that we have on the r, you know, when we use a square root, there's a 2 there. So to remove a square root, you just take that 2 and divide it by the exponent of the value. So that 2 will be like 2, the square root, maybe the exponent of the value divided by 2. So 2 divided by 2 is 1. So that's why we don't, after that, we no longer have an r that has that is squared, but we have an r, just simple one r, like r, no square root, no square, yeah, sorry about that. You see, rushing now. So just have r. So r is the same as r to the power 1. So we don't write a 1 because anything to the power 1 is just that value. It doesn't change, it doesn't do anything. It's the same as saying r times by itself, 1 times 1. No, not literally. Let's not complicate it. So r1, it's the same as r. So r to the power 1 is the same as r. So what we do on the left hand side, we do it on the right hand side. So we're gonna say square root of both these numbers now. Okay, both these numbers, but here, because we don't have because here r is not a value but a symbol to represent a certain condition. Okay, a certain calculation. What are we calculating for? What condition are we looking for? So r is not a number, it's not a value, but a symbol. So we have to get rid of the squared of the power 2. But here on a plus b, yeah, this is the same as a plus b all to the power squared. Okay, so here a and b, we have values. We have a value for a. We will be given a value for a, of which that is the real number, and the b, the imaginary number. So we don't have to square root both these things and to get rid of the square roots, but we can do that by calculating the value of a to the power 2 and the value of b to the power 2. So now if we have 1, we're gonna have 1 open bracket 1, okay, we're gonna get square root a plus, okay, a, we're gonna replace a with 1, and then boom, we're gonna close it, and then we say squared, 1 squared plus, maybe we have 2. Maybe the equation was saying 1 plus 2i. So b is imaginary number, so we're gonna say 2, and then close bracket again and put the square root. So what's the square root of 1? Sorry, what's 1 squared? 1 squared is 1. So we're gonna square root again and say 1 plus, what's the power 2 of 2? So 2 to the power 2 is equals to 4. So we're gonna have square root 1 plus 4, and then we're gonna add those numbers inside the square root. So we're gonna say 1 plus 4, so it gives us obvious 5. So we're gonna have a square root of 5. That is our r. Okay, that is our r. We don't go further than that. If you wanna put it in decimals, you can put it in decimals, but if you're not required to do so, don't do so. Just say square root 5. Okay, moving along, and theta is equals to arctan of b divided by a. So you get that. imaginary number divided by the real number. Okay, so we move. So we have this here, of which our r times cos theta plus I times sine theta. So here you see cos theta plus I sine theta. That is the CIS rule. Okay, that is the CIS rule. So here, let's say we were given okay, it's sorry, put that all inside bracket to the power 2, to the power of an exponent or whatsoever. Yes, so that's gonna be the same as saying so that n represents an exponent, so that we're just gonna times every value that we have here to the power of that exponent. So it's equals to r to the power n. So if it's 2, it's gonna be r squared. Okay, open bracket cos, because now we were given cos the number the cos, if it's 2, cos 2 theta plus I times sine 2 theta. Okay, so we multiplied everything by the exponent 2. Okay, so yeah, so cos theta plus I theta plus I times sine theta is the same as 1a plus bi. Remember back here we said a is represented by r times cos theta and b is r times sine theta. So this is what we have here. Okay, so I think r, not a modulus but a real number, whatever number that we will give in the value of that number. Okay, not modulus exactly, but yeah, the number that we begin. If you calculated the modulus and then the modulus, you find that it was square root 2, then instead of r, we're going to use square root 2. Or if there is a square root 4 of which that is equals to 2, you're going to use instead of r, you're going to put 2. Okay, it's simple, just like that. So yeah, moving along. So let's use the example that is here. I should have wrote it in a perfect form so that you can understand, but you're gonna see what I'm talking about. So here we have two numbers, an imaginary number and a real number. So the real number is 1, so that's a. Negative I, that's the imaginary number. Okay, so that's negative 1i. Instead of writing that 1, you're just gonna say I. So all in bracket to the power exponent 5 to the power 5. Okay, so let's use this to find the modulus. Okay, so remember a adds 1, okay, and then b adds negative 1. Okay, remember that, just remember that. All right, so yeah, let's move along. So I told a 1 to the power 2, so it's negative 1 to the power 2, that's 1. So that's 1 times 1. Negative 1 times negative 1, you get a positive 1. So 1 plus 1, you get a square root of 2. Okay, and then we move along. Because this is where we want to find the adjacent, so we're going to use arc10. So this is where arc10 comes along. So arc10 b divided by 1, d divided by a, and then arc10 negative 1 divided by 1, and our final answer is negative pi divided by 4. Okay, so it's just as simple as that. So we just, in the next video, we're gonna go into some of the equations that are related to this topic, and then yeah, you guys are gonna have to tell me, and then what do I need to do, what did I miss, what do you want me to explain. Maybe I'm not a good explainer, but I can try my best to explain anything that you want me to explain. Okay, yeah, other than that, guys, thank you for watching. Please like, subscribe. Yeah, support, guys, please support me. Like, I'm doing this because I want to help you, but if you don't want to help me, then I don't have the power to help you, because now this is the same as me doing videos for, you know, it is for fun, because I'm trying myself to love mathematics. But now, what support are you showing me to know we are having, all of us are having fun? Maybe you're not having fun exactly as I am, but come on, at least try to be there with me, support me, show me love and all that. And then yeah, we can work together, you know, we can be friends, we can make friendships, and then yeah, maybe all of us here will become friends at the end. Okay, so yeah, like guys, please hit the like button, hit the notification button so that you can get my notifications whenever that I post, and subscribe, guys. Like, it's simple, just please subscribe, and share this video with your friends. You know, watch it, explain to them. If you want to use this video to explain to them, just do that. You know, if you want to do presentations at whatever, at home, homework or whatsoever, at school, you just want to just hit me up and tell me in the comment section, so we need a video about this and that and that and that, and then I'll do it for you guys. Please, like, show some love and yeah, support. Thank you. Catch you on the next video. Okay.